Okay, so the last step of this problem is to find your horizontal asymptotes, okay? Um, and I have or end behavior right here because horizontal asymptotes can be funny. Okay, here's an example of a graph that has a vertical asymptote, it has a hole, and it has a horizontal asymptote. And nowhere did this graph ever cross that horizontal asymptote, which is at y equals 1. Okay, that's where the horizontal asymptote, it crosses the y-axis at 1. So nowhere will you ever have a dot on this graph, and nowhere will any of these dots ever have a y value of 1. Okay, no dot on the graph will ever have a y value of 1. The problem with calling it a horizontal asymptote always is that some rational functions, like this one over here, it has a horizontal asymptote. Okay, this one right here has a horizontal asymptote at y equals 0. But the problem is there is a place right there that has a y value of 0. Now, how can it have a horizontal asymptote and also have a y value on that horizontal asymptote? Well, that's why we don't always call them horizontal asymptotes. That's why we sometimes call it end behavior, because it is behaving that way at the end. This graph right here is approaching that y value of 0, and it's never, ever, ever going to cross it. But it did happen to cross it somewhere right here in the middle. So that's why sometimes it makes more sense to refer to horizontal asymptotes as end behavior rather than to call it a horizontal asymptote, because it's kind of confusing, because an asymptote is supposed to be a boundary line, a line where my graph can't go. And then my graph went there. Right there, it has a point. That's the point 2, 0. That point is on this graph, but I'm supposed to have a y-intercept at a horizontal intercept at y equals 0. Well, it does. It's just on the ends of the graph, not in the middle of the graph. So that's why I'm going to refer to it as not just a horizontal asymptote, but I'm going to say or end behavior. Okay. So, and you'll see in a minute, I sometimes I'll show you how I do my horizontal asymptotes, how I graph them. So this looks crazy, Bobobot needs DC. It's just a quick way for me to remember how to find the horizontal asymptotes, because it's really pretty easy. Notice that I did not write the factored form. I wrote the original form of the problem down because that's what I need. This right here, what I'm going to do is, in order to answer this question, I'm going to compare the degree. You compare the degree of the numerator with the degree of the denominator. And I have to point out, I am not sure that I've spelled that right. Compare. I don't know how to spell it, but anyway, just spell it correctly. I apologize for me not being able to do that, but that is one thing that I struggle with, is spelling words. Okay, so you just simply compare the degree of the numerator with the degree of the denominator. This is the degree of the numerator. This is the degree of the denominator. What did we find out about them? They're the degrees. Degree is also called an exponents. We learned this here. The exponents are the same. Okay, exponents are the same. Notice that is EATS. Exponents are the same. So the fact that the exponents are the same in the numerator as they are in the denominator, that's the degree of the polynomial. The polynomials are the same size. That means the exponents are the same. That means that the horizontal asymptote is going to be at y equals. Now divide the coefficients of those. What's the coefficient of that one? 1. The coefficient of that one is 1. So the y-intercept is 1 over 1, which is just a 1. And as I'm making this video, classes are changing and the hallway is extremely loud. So if you hear anything, you're hearing yourselves. Passing period. Okay, so exponents are the same. So my horizontal asymptote is at y equals 1. All right, so I'm going to go over here at y equals 1. Now I'm going to do past this x-intercept right here and out here past this. That's where that's the only place I'm going to put my horizontal asymptote, because I don't know if it's really going to cross in the middle or not. I think it is. Remember, we graphed it on Desmos, so I don't think this one actually does cross in the middle. No, it doesn't. It is a true horizontal asymptote. So you can go ahead then and draw this one all the way across, but again, we just kind of cheated by looking. Okay, so now that I've found all of these pieces, I've found everything. I've found the hole. I've found the vertical asymptotes. I've found the x-intercepts. I've found the y-intercepts. And I've found that the horizontal asymptote is y equals 1. And yes, I'm going to come back and explain to you what those are in just a second. I found that the horizontal asymptote is at y equals 1. You should be kind of ready to graph, okay? Now, here's what I know. I know that I am in this portion of the graph, I'm down here below. Okay, so that means that this is going to be going up like this, because remember, I approach an asymptote, but I never really touch it. This is going down here like that, and it goes on down here, and then it goes down here, and this keeps getting closer and closer and closer to that one, but it never touches. Now, that's kind of bad right there, so it probably does more like that. Let me clean that up a little bit. Okay, so this is what this one looks like. Okay, now here's how these usually work. If this here's your vertical asymptote. Since this graph is going down on this side of the asymptote, this side up here, it's usually going to be going up. Okay, not always, but you'll learn when that happens in in pre-cal, how to tell when you have them going toward the same way or going in opposite directions. But we know this side's going up, so that means this side over here is going to be approaching like this. Okay, so that's kind of how we have an idea of where our branches are. We do have a true horizontal asymptote in this case, so you can extend that. Oh, I'm all over the place. So you can extend that y equals 1 all the way across, or you can just leave it on the ends. That's up to you. As long as you have it shown on the ends, then you're okay. But this one truly is a horizontal asymptote. It never has a y value of 1. And that's the total graph. Okay, so let me go over here and do a couple of other Bobo Bottins eats DC. And I don't know why. I have a picture of Bobo the Clown holding a picture of Washington, D.C. and taking a big bite out of it. I used to have that clip art somewhere, and I've lost it over the years. But anyway, Bobo Bot eats D.C. This is how you remember horizontal asymptotes or end behavior, okay? Because when you're comparing the size of two things, okay, you can have x squared and x squared on top and x squared on bottom like we just had. This is exponents are the same. So you divide the coefficients. Okay, so this is where we got y equals 1 over 1. If there was a 2 in front of that one and a 3 in front of that one, then it would be y equals 2/3. That's where your horizontal asymptote would be. Okay, well, that's not the only way. You could have, if you're comparing the size of two things, they could be the same size, or you could have one bigger than the other one. Okay, so you could have x squared on top. Dadgum, I'm out of time again. You could have x squared on top, and you could have just an x on bottom. Okay, if that's the case, then we are bigger. We have the bigger exponent on top. Bigger on top. You see the bot bigger on top. So that means there's not a horizontal asymptote. And I got to stop.